number 8, we have the following piecewise function, and our goal is to figure out what a and b should be so that this function is both continuous and differentiable at where these piecewise functions meet, which is at x equals 1. So we've already done problems like this in this class when it comes to continuity, and when it comes to continuity, you just have to make sure that they meet at the same y value. So that's one condition. So we know that ax plus 4 and 3x squared plus b have to be equal when x equals 1 in order for this function to be continuous. So if we plug in x equals 1, we can see that this becomes a plus 4 equals 3 plus b. So the problem here is that we have two variables. We have a and b, and we can't figure out what those are at this case. So we need to move on to the next condition, which is we need this to be differentiable at x equals 1. So for a piecewise function to be differentiable at x equals 1, we can do a similar thing. We know that the derivative from the left and the derivative from the right have to be approaching the same value. So we can do the same strategy except with their derivatives instead. So the derivative of ax plus 4, so this is for g of x, now for g prime of x. So our derivative of ax plus 4 is a, and our derivative of 3x squared plus b would be 6x. Again, though, we know this is the case, or we want this to be true when x is equal to 1. So if we plug that in here, we get simply that a is equal to 6. So there's one answer. And now we can solve for b by plugging it back into the underlined equation here. Now we know a is 6. So this becomes 10 equals 3 plus b, which means b is equal to 7. So if a is 6 and b is 7, we get not only that this function is continuous, but that it's also differentiable.
The Teaching Center, UF's Learning Resource Center.